Hello everyone, welcome to the channel Statistica Hub. This will be the lecture number 1 for the course SH201A Probability Theory. Okay, in this course or in this particular lecture, we are going to cover some basic introduction to the probability. So let's start with the very basic discussion, like what is the meaning of probability? Okay, so like if someone say like what is an apple? So if I say apple, if I say pen, if I say like any particular name, what is a laptop? So whenever someone says something, there is some particular kind of image that our mind just generate. If I say apple, then I'm saying like, okay, there will be some red kind of ball kind of structure. That will be an apple. If someone say laptop, I will see some sort of like a image in my mind that will be like some sort of like a box kind of structure, maybe. If I say tree, then I will see that, okay, without like going outside, there will be some picture that will be framed in my mind that look like a tree. Okay, in a similar sense, if someone say to you, what is the meaning of probability or what is probability? So how can we start with understanding what is probability? So if I just break this particular thing and if I just see probable, okay, like this is like my way of understanding what is the meaning of probability. Someone can understand the probability in other sense, someone can define in other form, that's it. So like if I say how probable am I today to complete this particular lecture in the next 30 minutes. So that means to say I am talking about some sort of chance, correct? Some sort of likelihood. So we can simply see probability. It can be seen in the form of chance. It can be seen in the form of like, but we can say the other thing, maybe some sort of like likelihood, correct? That's how we can see the meaning of probability. So in a very simple format, without going to anything deep in the concept of like probability theory, probability measure, I will simply give one definition. What is the meaning of probability? So it is a measure of, it is a measure of likelihood. It is a measure of likelihood of, or we can say likelihood that a particular event, that a particular event will occur. Okay, very simple form. What is the meaning of probability? So it is some sort of measure that measures the likelihood that a particular event will occur. Okay, so we are having some basic terms in the context of probability. So we start with the concept of like experiment. Okay, so what is an experiment? So generally speaking, like what is the meaning of experiment? So we can simply say like experiment mean to say like, okay, I'm writing something. This is some sort of experiment. Okay, if I go and play, that is also some kind of experiment. If I do like any kind of action, any kind of thing that will result in some sort of outcome, that is an experiment. In very simple format, what is an experiment? Any action that results in some sort of like outcome, that is an experiment. Okay, now in the context of experiment, how the experiments are divided. So we can have different kind of experiments that I will just define like in the next slide maybe. So in this setup, I will simply write experiment is some sort of action that results in some outcomes. Okay, and eventually, like if you do anything, any kind of action, that will result in some sort of outcome. So whatever we do in the real world, they are some sort of experiment. Example, like you are going to the college, you attend the class. Now the point is you may be able to understand the concept of probability, or you may not be able to understand the concept of probability. So that is some sort of experiment. Okay, you write an exam, you may pass the exam, you may fail the exam. Again, some sort of experiment. Okay, you pass an exam with very flying colors, then also there may be a possibility that you may get some decent job or you may not get some decent job. Okay, different type of setups can be there, different kind of experiments can be there. Okay, now moving to the next concept, this is the meaning of experiment. Then for the experiment, you define something, outcome. I am writing something that is known as outcome. So what is the meaning of outcome? So what's an outcome? So we are simply saying that if you go and appear for some exam, you may pass the exam or you may fail the exam. So technically, these are the outcomes. So the results that we are getting, in the response of some particular action or some sort of experiment. They are known as your outcomes. So technically, these are some sort of results of an experiment. That's what we call as outcomes. Then we are having some sort of thing that is known as event. So what is an event? Event. So it can be defined in like different forms. I will go for like very simple format. Like if you go for any outcome, okay, like if I toss up a coin, then I know if I toss up the coin, it can either be like in head or it can be either in tail. So the outcomes that I'm getting, if I take them individually, that can be considered to be some sort of event. Okay, so technically there will be some more thing that to be defined that is known as your sample space. After that, we can just introduce the concept of event, but eventually I have written the event, so I will give the definition for the event. So a set of outcomes, a set of outcomes from an experiment, from an experiment is termed as an event. Okay, then we are having the new concept, sample space. So it is very simple. You simply write this as some S, that is just a set of all the possible outcomes, set of all the possible outcomes of an experiment. Okay, that's what we call like some basic terms in the context of probability. So you must know what is an experiment, what is an event, what is an outcome, what is the sample space. Okay, moving ahead, then let's start with some very general, very basic example. Let's say, let me give like two scenario. Let's say some example number one, you are having another example, example number two. So in example number one, I'm saying that I'm having a coin, and if I toss the coin, what is the probability that I will be getting a head? And I'm assuming that my coin is fair coin. Okay. On the other hand, let's take up another example. Let's say the example number two, I'm having some sort of like stone. And if I throw the stone, if I throw the stone in air, then I'm asking what is the probability that it will fall down. So there are two different problems. So what will be the answer for the problem number one and the problem number two, for the example one or the example two? Just think a little bit, then I will introduce like what is the meaning of probability and how do we introduce the concept of probability in different experiments. So one thing that we can observe, like this is some sort of experiment. I am having the coin, I toss up the coin. Experiment, I'll be seeing some sort of results. Okay, on the other hand, I'm having the stone, I throw the stone in the air. Eventually, this is some sort of experiment, it will fall down. Okay, so in this example, you are going to get the probability to be 1 by 2. Okay, very simple format. On the second case, if I say probability that it will fall down, so this will be coming out to be 1, correct? Like for a very general concept, like what is the meaning that, okay, what is the probability that the stone will be coming down to the earth? So we know that will be like certainly it will be falling down. So in that particular context, you can say the probability is coming out to be 1. Okay, but there is some sort of like glitch, or we can say some sort of catch. So the experiments that we defined, they can be of different forms. So generally or majorly, I'm going to cover two kind of experiments. One is known as random experiment, and the other kind of experiment that we deal with, that is your physical experiment. Okay. So coming to the concept, like what is the meaning of random experiment? What is the meaning of physical experiment? So we have to understand them like in a little bit detail. So moreover, our complete statistical courses that will be focused on random experiments. So we will go for like random experiments in some sort of detailing format. But for the physical experiment, I will just simply introduce like what is the meaning of physical experiment. So we are defining the concept of probability. So always remember one concept, that probability is defined, it is defined only in the course of, only in the course of random experiments. So if your experiment is random, then only you can deal with, or you can just say something about the probability. Like in this first example, you can say this is some random experiment. I will explain like what is the meaning of random experiment in the next slide. But assume that this is some experiment that is slightly different from this one. Like if I toss up the coin, then I know that there will be some outcome. It can be head or tail. Okay, and that is random. Okay, on the other hand, if I go for the stone example, in this example, when I throw the stone in the air, then I know it will be coming back. But you can see there is no randomness. Like I'm not the Hulk that I will throw the stone in there and it is like going to the space. That is practically not possible from my end. Correct? I'm just a human being. Okay. So like for me, that is practically not possible to throw the coin like with such a speed that it will be going in the space. Practically not possible. So if I throw the stone in the air, it is coming back due to gravity. So the first thing that we can observe over here is gravity. So this stone is coming back to the earth due to the gravitational pull by the earth. So in this particular concept, this is some sort of like physical experiment. On the physical experiment, I don't have like any kind of control. I'm not designing anything. This is coming back to the earth due to the presence of gravitational pull of the earth. That's it. That is the first concept that we have to understand, that in the course of physical experiments, we don't discuss probability. We don't discuss probability. The first thing that you have to take from this particular lecture number 1, you have to understand what is the meaning of probability, and we can define probability in the context of random experiments only. In the course of physical experiments, the probability can't be discussed. Okay, fine. Then moving ahead, then let's come to the concept of like a random experiment. So what is a random experiment? So is the experiment that is like very random? Let's try to introduce, like, let's say, let me take one example. Okay. Do I have anything? Okay. So just assume that this particular thing, like I'm having the writing pen. So I think for this one, I will not be able to generate some good example. So assume that I'm having some coin. Okay. Hypothetically. So if I throw the coin in the air, so if I just try to understand, that is some experiment, throwing the coin in the air. What about this randomness? That is the important point over here. You have to understand what is the meaning of randomness. It is not that, okay, I'm throwing the coin, or if I'm tossing up the coin in the air, it will be coming back as like Shahrukh Khan. No, he is not coming up, right? If I toss the coin, that is not possible that Shahrukh Khan is coming up, hey, hey, la, 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 la. That is not possible. So if I throw the coin or if I toss the coin, it will be coming up either as a head or as a tail. But I am not sure which particular outcome will be there at the final. Getting the point? So before the experiment, you know what are the possible outcomes, but we are not sure about what is the final outcome. That is the context of random experiment. So in a simple format, I can write an experiment with well-defined, with well-defined two or more outcomes, two or more outcomes. Okay, and these well-defined, you can just write one more point. These are predefined. Like before the experiment, you know what are the possible outcomes. So an experiment with well-defined or predefined two or more outcomes is a random experiment, given that we are not sure about the final event or the final outcome. Okay, that means to say, you know what are the possible outcomes. Okay, like in the case of like coin tossing, you know there can be head, there can be tail, but you are not sure which will be the final outcome. So this is some sort of experiment that is known as random experiment. Okay, so that means to say, with context of like random experiment, you can define like 2 or 3 different terms. So the first term, that is uncertainty. Okay, that means to say the outcome is not predetermined. You know what are the possible outcomes. There is like different thing that you have to understand. We know the set of possible outcomes, the set of possible outcomes, but we are uncertain, we are uncertain about the final outcome. Okay, and this concept is considered to be your uncertainty. Okay, then we have something that is known as reproducibility. That means to say an experiment can be repeated again and again under same conditions. Okay, that is simple, like experiment can be repeated under same conditions. Okay, so these are few of the terms that you need to understand in the context of like a random experiment. Okay, now let's move to some more terms, like the same terms that we just discussed. What is the meaning of sample space? So you generally write the sample space to be like S, or you denote by omega, and it is the set of all the possible outcomes, set of all the possible outcomes for an experiment, for a random experiment. In more general sense that I'm defining. So like, for example, you can consider maybe the coin tossing example. So we know the possible outcomes that we can see, that will be the S, there can be head, there can be tail. That will be the sample space. Okay, moving ahead with the second term that we already defined, the event. So generally people define event to be some event A. Okay, it is some subset of, it is a subset of sample space. Okay, so generally like we define the probability or we calculate the probability for some particular event. Okay, so generally probability is calculated for some event. Okay, that is the next term that we just defined. Sample space, we defined event. Like for example, in this one, you can simply say the event A to be getting ahead. Very simple. So in this one, the A that will be containing head only. If I'm having another example, let's say we are having some maybe dice. If you roll up the dice, then we know the sample space will be 1, 2, 3, 4, 5, 6. Now you can define some event A that will be getting ahead, getting an even number. So for the event A, I can be seeing the set to be 2, 4, 6. So that's how we define the events. Okay, so you can think about like a lot of random experiments, and along with this slide, like on the website, you'll find like one more slide in which there will be some decent examples, very basic examples. You can go through them. Okay, now let's try to understand more about the probability. So how do we define the probability for some event? Probability for an event, or probability of an event. Okay, so the point that I'm going to consider over here, that is like equally likely events. Okay, I just defined one more term, equally likely. Equally likely. Okay, this concept is valid only if the events are equally likely. Like in the next lectures, we will go for like more advanced versions. We will understand like what is the meaning of this thing. Like if I say that I'm having the coin, then you say the probability of getting a head, that will be 1 by 2. But who told you this concept? Like how that is coming out to be 1 by 2? On the other hand, you can think about another example. Let's say there is some ceiling fan. What is the probability that the ceiling fan, it will fall down? So we know in this case, the probability that is tending to 0. In the ceiling fan example also, I'm finding like it can fall down or it may not fall down. Two different events, but they are not equally likely. So they are not equally likely. But I'm dealing with equally likely events when the probability is same. They are having equal chance to happen. Like in the case of like the dice, then I know the probability of getting a 1 that is equal to probability of getting 2, and so on, the probability of getting 6. So these are equally likely events. So if I have to define the probability for some event A, then you write the probability to be, okay, so it will be simply number of elements in event A over number of elements in sample space. Okay, very simple. And in this concept, we are considering the events to be equally likely. So in the same example, let's say you are having the dice. Okay, the sample space will be S. We know it will be from 1 to 6. If I say event A, that is like getting an even number. So 2, 4, 6. So probability of event A, that will be simply coming out to be like 1, 2, 3, 3 over 6. I will be getting 1 over 2. That's how we calculate the basic probability and the rule of the probability. That's how it is applied. Okay. Now just write the general property or the general definition. So probability of any event A, that will be the number of favorable cases, number of favorable outcomes or the cases over total number of outcomes in sample space. So that's the first definition. For the equally likely events, we are writing the probability of any event A. Okay, I hope that makes sense and you're able to understand the concept of probability. Okay, let's move ahead. Then we are having some general terms or different type of probabilities that we define. So we can have certain event. So this is an event with probability of that particular event to be 1. So we call this particular event to be certain event, and this is also known as sure event. Like for example, like someone says, sir, now let's move to the same example. You are saying like, sir, when the stone is being like thrown in the air, it is coming back to the earth. So I can say that is some certain event. But the point is, in that context, we are not defining the random experiment. That is not a random experiment. Now you will say, sir, in this concept, how can we say probability to be 1? So on the same example, on the same experiment, the dice example, now if I say event A, that says getting a number less than 8. So if you calculate the probability for event A in this course, that will come out to be 6 over 6 and I'm getting 1. So this is defined for a random experiment. It is coming out to be some certain event. Okay, I hope now that makes sense. Now you can see the difference between like certain events and that physical experiment. Okay, then we are having some sort of events that are known as impossible events. Impossible events. So this will be an event with probability 0. Event with probability of A, that is 0. Okay, so in the same example, I can just define the event A in different form. Event A says getting a number greater than 8. So you see the probability of event A, that will come out to be 0. Okay, then we define the third kind of event that I can define. That will be your simple event. Okay, then like these are also known as elementary events. Okay, so this is an event with simple outcome, not simple but single outcome, sorry, with single outcome. Okay, like if I say in the same experiment, if I say what is the probability of getting 4, so like the getting a number 4, that is only like one outcome. So event says getting 4. So we know in A you can find only 4. That is one element, single outcome. So this is a simple event or the elementary event. Then you define something that is known as your compound event. So this is an event with more than one outcome. Okay, so that's how we define different type of events that you can make understand like what is the meaning of like certain event, impossible event, simple event, and compound events. I hope that makes sense. Now just move ahead. Then we define something that is known as complementary events. Complementary events. So what is the meaning of like complementary events? So if I say probable event A, that says like passing an exam. So event A bar, or you say A complement, that means to say not A, just opposite to A. So that means to say failing an exam. And we have the concept of probability of A plus probability of A complement, that will come out to be 1. That is the rule between the complementary events. So you have to understand what is the meaning of complementary events. Okay, these are more or the basic concepts about the probability, the introduction to the probability. There are like 2 more terms or maybe 3 more terms that I can just introduce in this first lecture only. So there are some events that are known as mutually exclusive events. So which events are considered to be like your mutually exclusive events? So if I just go for like, what is the meaning of exclusive? So you may have seen like many times if you go for the news channels, then they run up some particular kind of news and there is a banner that is just crossing the, or maybe some sort of like thumbnail, anything that we can call. It is just crossing up the window or maybe crossing up the news, and that says exclusive, exclusive, exclusive. So what is the meaning of that thing? On the other hand, if you go for maybe if you go to any particular showroom, let's say you go to Zara, maybe you're going to LV, maybe you go to like any particular showroom, then you'll find some sort of like collection of clothes maybe. And along with that, they just write something exclusive collection. So what is the meaning of that thing? So like we just see like the statistics of the probability in our day-to-day life, like every day. Every day you find something in the context of probability. Now let's try to understand what is the meaning of that exclusive word. So that word exclusive, that means to say you will be able to find this thing at this place only. That means to say that news that is running up on channel number A, you will not find the same news on any other channel. That's why they are writing the exclusive news. On the other hand, the clothing setups, they're also writing the exclusive because they are saying that the meaning of that exclusive that says that you can find this particular dress at this place only. You will not find this particular dress at any other showroom or in any other company, maybe any other brand. Okay, so that means to say the events that are having nothing in common. Okay, on the other hand, you can simply say the events that are nothing in common, you can simply say the disjoint events. The disjoint events. So they are considered to be mutually exclusive events. Then we have another concept that you have to understand, that is the exhaustive event. Okay, so in this concept, like you can simply say there is nothing common. So we are having like 2 operations. This is like your union and this is the intersection. Okay, this counts or this counts and mean to say like me and you. That mean to say me and you, we both are coming somewhere. Or in other sense, if I say me or you, that means to say either you or me or we both of them. Okay, so the exhaustive events, these are the like, okay, I'm going to disjoint events. So in this case, if you say probability of A and B, that will be coming out to be 0 because there is nothing in common. So there will be no element that is common in A and B. So the basic probability rule, number of elements that are favorable divided by total number of elements, that come out to be 0. Okay, then we are having the exhaustive events. So in the exhaustive events, the events that take up the complete sample space. The complete sample space. So these type of events are known as exhaustive events. Okay, like if I say like maybe the coin example, if I say event A says that getting a head, event B says getting a tail. So we know if we take like A and B, both the events, like A or B, technically not and, then you can see the head that has taken up, the tail that has also been taken up. So these are coming out to be like exhaustive events. On other hand, if I go for the dice example, then you can see in the dice example, if I say A event that says getting a number greater than 2, and in event B, if I say getting a number less than 5. So you will find in this one, there will be 3, 4, 5, 6. In this one, you will find 1, 2, 3, and 4. The sample space that was like 1, 2, 3, 4, 5, and 6. Okay, So you can see 1, 2, 3, 4 taken up, 3, 4 taken up, 5, 6 taken up. So the complete sample space has been taken up. So these two events are considered to be exhaustive events. Okay, so that means to say if you find probability of A union B that is coming out to be 1, then this is considered to be exhaustive events. Okay, that is the concept of exhaustive events. Now there is like one more concept that is known as partition. Okay, so technically partition of sample space. So how do we go for like the partition? So you can see in the partition, like if I go for maybe someone is living in the joint family. So in the joint family, if I go for like my family is going out to be like in the partition format. Okay. Or maybe we are breaking into like two nuclear families. Assume that me and my brother, we are breaking up and we are just going for like, okay, bro, you will live alone, I will live alone, we will be having like separate life, the nuclear families. Okay, so in that context, like if I just say our complete property or something, that can be considered to be like our sample space. Okay, when we go for the partition, then we know anything that we combine, whichever like in his part or whatever is there in my part, if we combine that portion, that will be coming out to be the complete sample space, whatever property we are having. Like one example. And if I go for like the partition, then there will be some more concept that there will be nothing in common between him and me. It will not be there that okay, we may be having some kind of land maybe in Delhi or maybe some land in Gurgaon. So it is not possible for him to have some share in my land, or I will not be having any share on his land. So that means to say our events, they will be mutually exclusive plus exhaustive. So that is known as the partition. So some events, so events that are mutually exclusive plus exhaustive, they make the partition. Okay, so this was some concept about mutually exclusive events, exhaustive events, and the partition of sample space. So this was about the first lecture, and this was something about introduction to probability. I hope you are able to understand. Stay connected and move to the lecture number 2 to go deep dive in into the concept of probability. Thank you.